Hi my friends, today we model this part which has some problems. The drawing is this, and you see a wall between these two chambers which must be created by using special modeling. The source is again a drawing of Timoteo Carrera Soto, our friends. You see here the body we have to model, which is the body of a whistle for the locomotive, I suppose. This part is taken from Timoteo Carrera Soto drawings, and you can download it by watching the tutorial number 182. We start by creating this contour you see here, external, as a revolution volume. It has a thread here of 7/8 inches. You have here all the necessary dimensions. We start with 93 as the axis. New standard millimeters IPT. First sketch, XY plane, line, up 93, this is a center line, and we continue with the lines. This is the first, down, left, down, right, again down, then somewhere here, restart. We start from the bottom to the right, up, left on the same vertical with this, then an arc between these 2 points with a radius of 28 is the dimension in the drawing. This point is placed on this axis. The distance from the bottom to the center is 43. Other dimensions. This is 30.201, and I'll show you where does this come from. Then this diameter of 38, this common with this 28 diameter, 11 here, 96 is this flange. This is 28. This is 3, and this is 2, and the total dimension here is 15. This is 15. Now we have a fully constrained sketch. we apply revolve, and we have the first volume. Okay, I want to tell you about this dimension measure. This is 30 millimeters and 201. Where does this come from? It comes from a table which is present in your Inventor files, but I can show you quickly how to find it. You see, this is what you need to know. Fast group dot row, which has this prefix, of course, but is enough to use this only text. Then you go to tutorials, where you have a lot of assets. The most interesting is this one, general index table, which contains all the tutorials, my friends. Yes, all the tutorials updated to this very day. Look here, how many are here, and the last is this one. You can click on this link to get access to that tutorials. Other asset is this one we use now, thread for pipes, which is present in your furniture of Inventor. Click here and you have a new table, another table with all the threads. We don't use internal taper here, but a thread, an external thread. We go to gauge 7/8 and we see here the diameter, external diameter. This is the way to know what is the start for such a thread. Okay, having that dimension, we can create the thread very easily. We select this and ease of pipe threads, and you see here directly gauge 7/8. Okay, this is a chamfer of 1 millimeter. Okay, and we apply also fillets of 4 to these 3 edges before adding other features. Next is this horizontal revolving volume with dimensions. Important thing is that the distance from one end to another is 33 plus 33. So, and the distance is 43, which means on the center of the sphere, of this sphere. We use this plane XY, F7. I project this as a construction entity, and I draw a horizontal line of 33 plus 33. We place this midpoint right here so that we know that 33 and 33 are on the both sides. Line up, then around, horizontal to the center, then smaller diameter to here. This line must be coincident with the center of the sphere. This is radius 2. And we add a fillet with radius 2 between these two entities. Dimensions, this is 38. The other one is 34. This one is 16. And we have a fully constrained sketch. Finish sketch. Revolve. Okay. Once again, I place fillets of 4 millimeters on these two edges. Then we create this internal volume, but only this and what you see here, this another sphere. This must be written radius 24 spherical, as well as this one radius 28 spherical. We also take care of this 16 and a distance of 13. This hole will be created after this because there is another dimension here of 5/8 inches, which I don't find the diameter, internal diameter here, and so on. We apply this dimension for a hole. This is better than this, which must be created to apply thread. Yes, there is a difference here. Okay, XY plane, F7. Now we create this internal contour, this at the left, and another one with this radius of 24, which must be spherical. Both this one and this one must be noted as spherical, but you see what is here. So we have to draw the second close contour, this with this radius 24, then go here and 16. You see this dimension of 13, radius to here, radius to here. Let's create this internal closed contour, two closed contour. The plane is XY, F7. I draw a line from midpoint to midpoint. I apply here center line and I draw lines. This is the first, this is the first, then to the right, down. Another one is based on an arc with center point. From this center, which is the center also of the sphere, I draw an arc from here to here. Lines. This one's dimensions. This is 30 and this is 4. This is 20. Oh, they were not coincident. Now they are. This is radius of 24. This is 16. And this is 13. We can add this line instead of a hole. It finishes here and we split this line to make a construction segment, then a diameter of 8. This is a hole. We could place it after, but now is also well. I don't create here that threaded hole because I don't know the internal diameter. This was another thing. We were forced to create external and apply thread, but here I will apply a hole of 5/7. This is 5/8. This is the diameter. Yes, you understand me. I will place a hole here, but not also here. This 8 is now added here. Fillet this and this. Yes. Now we have all dimensions. This is a fully constrained sketch, and we can apply revolve. We have two areas. This is one, this is the other. The axis is known and the option is cut. Now we can apply that hole, which is isopipe threads, gas 5/8, on a distance, full depth, the distance is 20 minus 4. Okay, this is the definition. This is the face, this is the center, and okay. Next is this hole, 20, through all the part. Hole, not threaded, through. This is the center, the face, this is the center, and the dimension is 20. Okay. Now we have to create the most difficult feature, which is this wall between the two chambers. We have dimensions here and also here. 9. This 9 is important now, and also this radius 28 of the external sphere, the radius of 24 of the internal sphere, and you see some arcs and lines here and there, offset on the other side. Keep in mind these dimensions and also that 9. XY plane, sketch, F7, and we project this contour. We draw a line from this point to here. I don't need this line, and I trim the bottom end. This is a center line, and it must be coincident with the center point. Now I apply revolve of the half of the circle, and we have a new solid. Not a join, not cut, not intersect, but new solid. Okay, let's call this as wall, because this is the first step to create this wall. Good. If you want to see better what happens, I change the properties, I mean the color, to red. Okay, now we have a sphere over another sphere. Yes, we can hide the main body to see only this sphere, but I go back because I need it. Now another sketch, F7, where I use this projection and this generator. Both must be construction. Then I use that dimensions, but I change the default color of the lines in order to see what I do. I create a vertical line, then an arc which goes to here, and it is tangent to this arc, with dimension of 7, radius of 7. This distance is 5. Then I continue with lines which are arcs by keeping pressed the left button to go here. Then I also keep pressed the left button to go on this. I make tangent, these two. I apply the distance of 9 as I mentioned before, the radius of 8.5, and also 8.5 here. Then, since we have a fully constrained sketch, I apply offset of 5. This to the left at 5. I trim this end, but here is missing. Ctrl Z. I project also this, and also construct to apply trim. As you can see, we also see a gap here, so that I draw this short line, and I also draw an arc from this point to this point, identical with the contour. Here I trim this end arc, and I connect that point, which is this one, with the other from here, to have a close contour. Now we have a close contour. Yes, yes, yes. Finish sketch, extrude. Now be careful. We have to select the solid which will be connected with a new object, and I select this volume. Then, as you can see, we have the contour here inside, and we select symmetrical all the way, and not join, not cut, but intersect. Okay. If you want to see better what is inside, I hide this initial body, and we see what is inside. I go back with visibility, and I apply combine, selecting this and not this as the base body. I select this, then I select the other, and I apply join this time. The color is gray, and we can see inside. If we go to view, half section view, XY plane, and you see what is inside. Now we have to apply this cut with this extension. There is an extension which is better seen here. 1 millimeter from that side of the wall, and a hole with a diameter of 16 with a chamfer here to support this diameter of 20, which is also present here. Sphere of 20 must be placed on this chamfer, not on this edge, not on this edge, but in between the two, in the chamfer, on the chamfer. Good. You see dimensions here, remember 9 and 1 here, and the angle of 60 degrees. We start by creating this extrusion or revolve. I use revolve. XY plane, project this and also this to have a center, and I place here a rectangle which has a coincidence of this line with the midpoint from here, because this midpoint is other. This is not symmetrical. Then I make this center line. I place dimension of 1. And the diameter of 20. From here to the center line is 20. Finish sketch, revolve, and you can see here what happens. Not a new volume, but a join. Okay. The internal revolution is on the same plane, line from here down and here back. I also draw this line. This is construction. We project again this line to apply coincidence between these two. This is a center line. Dimension. This is 16. Now we go here with this and we apply half of 60 degrees here. 60 divided by 2. And the distance of 1 millimeter between this line and this point. Okay, now we verify that sphere can be placed here with a tangency on this short segment. I draw a circle with diameter of 20. I place it on the axis and I move to be tangent with this. We can see that the point of tangency is inside this line. This means that we respect the drawing from Timoteo Carrera Soto, our friend. Finish sketch, revolve with cut. Okay. Oh, I forgot to make coincident this. I really forgot. I project also this line and I make collinear these two entities. Now is okay. You see here. Now we have to apply these fillets, radius 2, radius 2, radius 2 inside that internal volume, since we have access to it. I select this small face edge to apply 2 millimeters fillet, also here, also here, here and here. Yes. This must be also with that fillet, and that's all. Okay. Here is another chamfer of 1 millimeter. I don't want to forget. 1. Okay. And I think everything is okay, so that I can delete the section view. Next is this fork. This is a fork, yes. This. Its dimensions are here. 60 is the distance, 48 is the other distance. A hole of 8. A radius which is missing, I place it now, is also 8. This radius, and with a cut of 8 with 11. Let's do this construction. I adopt a special way of construction. I use this plane as a base. I place it at a distance of 48 plus 8, because that is the radius external. Okay, and I create here a rectangle with dimensions on vertical 8 multiplied by 2, tab, horizontal 16. Dimensions in the drawing. Then I place, you see is green because I didn't change here. I go back to default, but this is not important. Then I project. Now I have this center point. I place this center on the same vertical. Oh, this is horizontal. On this horizontal, these two, and a distance from this point to this center of 60. Now you'll understand why I created this rectangle, because now I extrude that rectangle to the part. Okay, I hide this, then I apply a radius of 8 and also 8 here. It was 6. Okay, then I use this face to apply another rectangle based on this line with the width of 8 tab and a length of 11. These are wrong because of orientation here. This is 8 and the other is 11. This midpoint must be on this midpoint. Finish sketch, extrude this with cut to this face. Okay, now we have to place that hole of 8 millimeters on this face with this center through 8. Okay, good. Another fillet of 2 millimeters is here and also here, as in the drawing. The last things to do is to place these holes, these 4 holes, 4 of diameter of 8 on a circle of 72. This face F7 line from the center point to the right, that's 72 divided by 2. Finish sketch, hole placed right here of 8 millimeters through the part. Then circular pattern of the last feature, this one, about this axis in a number of 4 instances. Okay, that's all. We can see inside everything, and now we take a look at the volume. Physical update, copy, close, drawing, double click, paste. There is a small difference at the 5th rank. You see, this is the 5th rank. This is not important at all. I eliminate the first value and I keep this because this is what we did today. Let me apply the material, which is steel carbon, then the color, which is yellow, and I select some faces to be machined. This one I keep pressed the shift button, shift key from the keyboard. This is wrong. Now I see that this is wrong, my friends. That dimension is 11 from the center. Yes, from here. I eliminate this and I place a dimension of 11 from this. Finish sketch. Once again I search for the volume. Nobody is perfect, my friends. The age knows better. Copy, close, fit, drawing, and the value. Now we have a smaller value, but this is what we did today, and I don't want to search more because all we did is here and the result is this one. Then I go back here to place that machine faces, this one, this one, this one, this, and the bottom. Not yellow, but still polished. Okay, that's all for today. Thanks for watching. Bye bye.